Problem 3 says state the limit definition of the derivative f of x. So there are two acceptable answers. F prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. So this is the equation or the definition that will return an equation of x, and that would give you all possible derivatives. Alternatively, you could state f prime of a equals the limit as h goes to 0 of f of a plus h minus f of a all over h. Using this definition, this will return one specific slope at location x equals a. So both are acceptable definitions to put on the test. You only need to provide one of them. Part B says, well, let's apply this definition of the derivative to calculate the limit, or the derivative, excuse me, of 1 over 1 plus 2x. So what I like to do is I like to try to do as much of my algebra up front, so that way I'm not having to write limit again and again and again when I'm doing all of my algebra steps. So the first thing I'm going to do is I'm going to look at f of x plus h. So this is going to be 1 over 1 plus 2 times x plus h. And when I expand my denominator, I get 1 plus 2x plus 2h. F of x is just the original function. Since I have a rational expression here, I'm going to go ahead and try and simplify my numerator a bit. And I'm going to do the difference quotient first. So the difference quotient is just the stuff inside the limit, right? I'm just going to simplify this expression before I actually take the limit of my result. So f of x plus h minus f of x all over h. So when you're dividing by h, when you're doing rational expressions, that is actually the same thing as saying I'm going to take the numerator and multiply it by 1 over h. And this will save you a little bit of paper and space. So f of x plus h is 1 over 1 plus 2x plus 2h minus our second rational expression of 1 over 1 plus 2x. So I'm going to need to get a common denominator to combine these two functions. So that means I'm going to multiply this by 1 over by 1 plus 2x, and I'm going to need to multiply this by 1 plus 2x plus 2h. My common denominator will end up being these two things multiplied together. So once I've done that step, I'm going to have 1 over h. 1 times 1 plus 2x is 1 plus 2x. Then I need to make sure that when I multiply this, I put it in parentheses because this negative sign is going to need to get distributed across. So I'm going to multiply the second piece by 1 plus 2x plus 2h. And all of this will be over my new denominator of 1 plus 2x plus 2h times 1 plus 2x. So if I look in the numerator, I can see here that this 1 minus this 1, right, adds up to 0. This positive 2x minus this 2x adds up to 0. And all I'm left with is negative 2h in the numerator over 1 plus 2x plus 2h times 1 plus 2x, and all of that is still multiplied by 1 over h. Now my h's cancel, and once that h in the denominator is gone, now I'm ready to set up my limit. So f prime of x is equal to the limit as h goes to 0 of negative 2 over 1 plus 2x plus 2h times 1 plus 2x. So when I plug in 0 for h, I get negative 2 over 1 plus 2x times 1 plus 2x, which is negative 2 over 1 plus 2x squared. If you were to check this problem using the chain rule, so you don't get any credit for using the differentiation rules, but you could always check the answer to your limit by using the differentiation rules, because your final answer of your limit should match that rule. So this would have been a chain rule problem, and you could always verify doing that. So very quickly, I'm going to verify my answer. So down here, I'm going to check. So f of x can be written as 1 plus 2x to the negative 1. So then f prime of x would be negative 1 plus 2x to the negative 2 times 2, which does in fact equal negative 2 over 1 plus 2x squared. So I can see that that matches my limit. So you can always check yourself on your scratch paper or down at the bottom of the problem.